Okay, so the question that we have here is a sample of an organic compound contains 0.624 gram carbon, 0.065 gram hydrogen, 0.364 gram nitrogen, and 0.208 gram oxygen. What is the empirical formula of the compound? Then B, if the relative molecular mass of the compound is 194, what is the molecular formula? And then we're given that the relative atomic masses of carbon is 12, hydrogen is 1, nitrogen is 14, and then oxygen is 16. So how do we go about looking for the empirical formula and also the molecular formula? So, so to look for the empirical formula of a compound, what we'll do here is to first of all look for the number of moles of each of the elements and then divide by the smallest, right? That is how we get the empirical formula. So let's also put the solution here. So we know that mole is equal to reacting mass. Mole is equal to reacting mass over molar mass, right? That's the formula for mole. Reacting mass over molar mass. So the number of moles of carbon in this compound is equal to the reacting mass of carbon, which is 0.624 grams carbon, right? So that would be 0.624 grams divided by the molar mass. The relative molecular mass is what? 12. So that is 12 divided by 12. And that will be equal to 0.624 divided by 12. If I bring out my calculator, 0.624 divided by 12 is equal to, that will be equal to 0.052, 0.052 moles, right? So this is the number of moles of what? Of carbon. Then I'll also look for the number of moles of what? The number of moles of the next element, which is hydrogen. So this is hydrogen. Like I said, mole is equal to reacting mass over molar mass, right? So what is the reacting mass of hydrogen in this compound? It is 0.065 gram of hydrogen, right? So that will be 0.065 divided by the molar mass. The molar mass of hydrogen is what? Is 1 divided by 1. So 0.065 divided by 1 is equal to 0.065. Then the next element that I have there is nitrogen. Nitrogen, right? And then I was given the reacting mass of nitrogen in this question to be 0.364 grams of nitrogen, right? So mole, like I said, is reacting mass over molar mass. So the molar mass of nitrogen is what? Is 14, right? So the number of moles of nitrogen will be equal to the reacting mass, which is 0.364 divided by the molar mass, which is what? 14 divided by 14. So 0.364 divided by 14 will give us 0.364 divided by 14 will be equal to, that will be equal to 0.026, right? So 0.026 moles of nitrogen. Then the other element that I have there, the last element that I have there is oxygen, right? So we are given that the reacting mass of oxygen is 0.208 grams of oxygen, right? So 0.208 grams of oxygen divided by the molar mass of oxygen, which is 16. divided by 16, and that will be equal to 0.208 divided by 16 is equal to, that is equal to 0.013, right? 0.013 mole. So these are the moles, the number of moles of all the elements that are in this compound, right? So like I said, to look for the empirical formula of a compound, the first thing you do is to look for the number of moles of each of the elements. We've looked for that. So these are the moles, right? The number of moles of each of the elements. Then the next thing you should do is to divide by the smallest number of moles. So if I look at all this value, which is the smallest? The smallest is 0.013. This is the smallest value. So what I will do is to divide all through by the smallest value, right? So the next thing I will do is to divide by the smallest number, right? By the smallest value. Is to divide by the smallest value. Divide all through by the smallest value. So here I have 0.052 divided by the smallest value, which is what? 0.013 divided by 0.013. That's for the carbon. Then hydrogen will be 0.065 divided by what? 0.013. That's the smallest value, right? Then nitrogen will be 0.026 divided by the smallest value, which is 0.013. Then oxygen will be 0.013 divided by 0.013, right? So having done that, the next thing is now to divide, right? So I have 0.052 divided by 0.013. 0.052 divided by 0.013, that will be equal to 4, right? So here I have 4. 0.065 divided by 0.013. If you punch that in your calculator, 0.065 divided by 0.013, that will be equal to 5, right? So I have here to be 5. 0.026 divided by 0.013 will give us 2. And then 0.013 divided by 0.013 will give us 1, right? So therefore, the empirical formula of the compound will be C. So the empirical formula now, the empirical formula let's just represent it as this. The empirical formula will be equal to, the carbon is what? Carbon is containing how many atoms? 4 atoms, right? So that will be C4. Hydrogen is containing how many atoms? 5 atoms, right? H5. Nitrogen is containing how many atoms? 2 atoms. N2. And then oxygen is containing how many atoms? 1. And 1 times 1 is an insignificant number. 1 times oxygen is still oxygen. So O. There is no need to write O1, right? So that is O. So the empirical formula of the compound is C4H5N2O, right? This is the formula that shows the ratio of the simplest ratio of each of the what elements in this compound. So like I said, to look for the empirical formula of a compound, first of all, look for the number of moles of each of the elements, and then after looking for the number of moles, how to look for the number of moles? Reactive mass over molar mass, right? So after looking for the number of moles, the next thing is to divide by the smallest value. and then you will get the number of atoms in each of the elements. And that is what we have here, right? So the next thing that we have, the next question that we have there is, if the relative molecular mass of the compound is 194, what is the molecular formula? If the relative molecular mass of the compound is 194, what is the molecular formula? So how do we look for the molecular formula of this compound? So the molecular formula is a whole number multiple of the empirical formula. I've mentioned that before, that the molecular formula is a whole number multiple of the empirical formula. Very important. So if I should represent that, this will be C from the empirical formula. We have C4H5N2O, right? C4H5N2O, right? Is equal to, this is open bracket, close bracket, N is equal to the relative molecular mass of the compound, which is 194. So we're solving B now. B. Here we solved A, right? Here we're looking for B. Again, if the relative molecular mass of the compound is 194, what is the molecular formula? So like I said, the molecular formula of a compound is a whole number multiple of the empirical formula. Is a whole number multiple N of what? Of the empirical formula. I repeat that again. The molecular formula of a compound is a whole number multiple N. That's N multiplied by the empirical formula will give you what? The molecular formula. So it's a whole number multiple of what? The molecular formula. So what we are going to look for here is this N, right? So the next thing that we're going to do here is to look for the relative molecular mass of this compound, right? So the relative atomic mass of carbon is 12. The molar mass of carbon is 12. So that will be 12 times 4. That's 12, which is the relative atomic mass of carbon times 12. Plus hydrogen is what? The relative atomic mass of hydrogen is 1. So that will be 1 times the 5 here. So 1 times 5 plus the relative atomic mass of nitrogen is what? 14. So that will be 14 times 2, right? 14 times 2 plus the relative atomic mass of oxygen is 16, and I just have one oxygen here, right? So times plus what? Plus 16. Bracket close, N equal to what? 194. So 12 times 4 will give me 48 plus 1 times 5 will give me 5 plus 14 times 2 will give me 28 plus 16 open bracket close N is equal to 194, right? So this will be 48 plus 5 plus 28 plus 16. 48 plus 5 plus 28 plus 16, that will be equal to 97. So I have 97 times this N will give me 97, N is equal to 194. So N, to look for the value of N, I will have to divide both sides of the equation by the coefficient of N, which is 97. So that will be equal to 194 divided by 97. And that will be equal to 194 divided by 97 is 194 divided by 97 is equal to 2. So that will be equal to 2. So that tells me that my n, the whole number multiple, is what? Is 2. So what I have in essence is that I have C4, H5, N2, O, bracket. So the value of n is what? Is 2, right? So I'm going to put 2 there. 2. So 2 times 4 will give me what? C8. 2 times 4 will give me 8, right? 2 times 5 will give me 10. H10. 2 times 2 will give me what? 4. N4. 2 times 1 will give me what? 2. O2. So this is the molecular formula of this compound. It is equal to C8H10N4O2. And this compound is caffeine. Caffeine. This is the molecular formula of caffeine.